Okay, so what's the difference with this one compared to our other ones? Alex, what do you got? Okay, good. Looking at the equation, yeah. Good, there's that negative outside the square root. And as Alex said, that's going to change the picture that we end up with. Okay, so we have now negative x plus 2, the root of x plus 2, all minus 3. Okay, and so going through and trying to fill that in, remember, we're trying to make this thing inside here become, what do we want x plus 2 to equal?
0.
Good, we want it to equal 0. Okay, that's our first one. So if we can get that root to equal 0, what do we have to plug in for x to make that happen?
Negative.
Negative 2. Okay, so when x is negative 2, I'm going to notice how I write this. I'm going to still keep that negative up there. That's like having a negative 1. Okay, so I have negative 1 times the root of 0. X plus 2 became 0. And we're subtracting 3 from that. So, what's the root of 0? 0. Times negative 1. 0. And we have to subtract 3. Negative 3. Okay, so with that negative, we just wait until we get the root, and then we multiply by negative 1. So the next thing we want the inside to be is?
1.
Good, x plus 2 has to equal 1. All right, so if we subtract 2 on both sides, x has to be negative 1. So when x is negative 1, we have our negative 1 out here. Okay, and we have the root of 1. All minus 3. Root 1 is? 1 times negative 1 is? Negative 1 minus 3? Negative 4. Okay? Now we want our root, the inside of our root again. We want it to equal 4. X would equal 2. So when x is 2, our root becomes 4. So root 4 is 2. 2 times negative 1. Negative 2 minus 3. Negative 5. Any questions up to there? Let's go one more. Let's make our root equal. X plus 2 is going to equal 9 now. Subtract 2 minus 2, we get x equals 7. So when x is 7, our root is 9. Root of 9 is 3, which makes that negative 3, and negative 3 and negative 3 is negative 6. Okay, so if we plot our points now, negative 2, negative 3, negative 1, negative 4, 2 and negative 5, and 7 and negative 6. Okay, so this is where our graph looks different than all the other ones we've done. Okay, Ashley pointed out, hey, there's a negative outside the radical here. Notice how that changes our picture. Okay, it makes, like Alex said there, it makes our graph open downward. Okay, so we get negative 2 and negative 3. That's our vertex. So that's that point right there, our starting point. On today's assignment, I haven't listed a place for you to list the domain and range. What I want you to do is just to write into the last 2 spots of your tables, domain and range. And we're going to add that in there. Okay, so our domain is x is going to be, and range is y. And we know negative 2 goes here and negative 3 goes here because it's always that point. It's always what makes this 0 and what's out here. We just need to know what goes in between. Okay? So, tell your neighbor what you think. What goes in between?
Negative 2.5.
Come on, dude.
It has to be for your range.
Oh, what do you mean? What goes between x and negative 2?
Yeah, what goes in between x and negative 2 and
So
y and
the
negative
little
3?
alligator is facing the negative 2. Less than symbol or whatever.
Yeah, it has to be.
So it's going down, turn the other way. What's it called when the little alligator is facing that less than?
It's called scary, man. I don't like alligators facing.
I like them. I just don't want to be.
If it points to the left, it's less than. If it points to the right, it's greater than. Hey, how many have an answer? Okay, guys, I'm going to focus in once again on the x-axis. So, right here, I'm going to just draw the x-axis. Remember, the x-axis is just a measuring stick. It starts at 0. Now, in context of this problem here, our point, our vertex, is right down here, right? Like here's 0, and our vertex is there. Everyone get that? How many are with me? What we're doing? Okay, so from this, our graph kind of looks like that, correct?
Yeah.
It's just a quick sketch. If this is the x-axis, these are all of our negatives, these are all of our positives. Is this graph on the x moving this way, is it going towards positives or negatives?
Positive.
Positives. So that just means it's greater than, and it can be that point or equal to. So you've got to think of the axes as individual measuring sticks. Now, how many said that? How many said the other way? It's okay. The point is to understand why. Okay, think of x, draw it like this if you need to. Okay? And then let's think of the y-axis also as a measuring stick. So I'm going to slide that up a bit. Here's our y-axis. Here's 0. This is our measuring stick. We have all negatives down here, all positives up here. Our point, once again, here's 0. Our point relative is just somewhere over here. You guys with me?
Yeah.
Okay? The graph does something like that. Now, did it open down towards the negatives or open up towards the positives? It went towards the negatives, which means this is less than. Okay? How many got it? Hey, so an extension, any questions on that? Ashley?
Could we just leave it as a numbers and say that like negative 3 is less than like all the ones, or it's greater than all the ones, so it would be like,
If you flipped it around? If you put negative 3 first, is
no,
that
I have what you have up there.
okay?
But instead of doing like the graphs and stuff, could you just do like negative 2, all the numbers get bigger?
You could, yeah, if you can see that. Like you see that, right? Some people don't see that. You don't have to draw these. The only reason I'm drawing these is to show the students that are having a hard time with it. Okay? But you're right. Yeah. Kimmy.
So the reason why negative 3 is greater than y, is that because like y is decreasing and the graph is decreasing?
Correct. It's because the graph is decreasing. Yep. Yep. It's going downward from this point. It's getting small. All the values for y are going down. They're getting smaller. So yeah, if you looked at this, as x is increasing, y is decreasing here. Okay? Hey, really quick, just a quick extension. If this is my graph, I want you to draw just a quick sketch of a function. You don't have to do anything other than something like, like that. Okay? Now I messed up my graph, so I'm going to use one of these now. Okay? I want you to draw a square root function that would have a domain of x being less than or equal to something. Let's say 0. So now you have to be more specific. What would a picture look like where x is less than versus greater than? We haven't seen one of those yet. Okay, show your neighbor what you got.
Oh. I think that's actually right.
What's your sister's last name?
Yeah.
I barely heard your last name.
All right. Hey, I am highlighting my x-axis here. Here are the negative parts, and here are the positive parts. If I'm starting at this point, right, if it's at 0, that's that point. How many with me so far? If I want it to be less than, which way do I need to go? I need to go to the left, towards the negatives. Now, it really doesn't matter if I open upward or downward in terms of x. It just has to go that way. Now, this is an x is less than or equal to, and a y is greater than, because it went upward on the y. If I would have opened it down here, then it would have been y is less than also. Okay? Are we good on that? Okay. All right. Hey, today's assignment. You got it in front of you. It's this packet. I know before you freak out that it's 15 problems. Okay? You're doing the same thing we did yesterday, with the exception you need to write in domain and range at the end. And when you get to one like negative 2.5, number 2, don't freak out. Right? You still are trying to make 0, 1, 4, 9. It just means you're going to have a bit of a decimal there. F of x is the same thing as what? Y. Okay? There you go. You can work together if you're working quietly. Make sure you're asking if you have questions.